I'm next going to hand over to Dr. Keith Deere from Fujitsu, who's going to be presenting on revolutionizing decision-making for individuals and organizations. So Keith, over to you, please. And your screen has just come through.
Superb. So hopefully you can hear me and see the slide. And on the slide, it should start with revolutionising decision-making for individuals and organisations. So I'm Managing Director of Fujitsu's new Centre for Cognitive and Advanced Technologies, within which we have the Digital Twin Programme Office, which is managing building the global reference model for connected digital twins in the UK on behalf of Fujitsu Global. And I'll come back to what that means in a minute. But in the centre, we have the mission to revolutionise decision-making, and we have a single KPI, the number of new-to-market, new-to-firm inventions as a percentage of UK total contract value. Why does that matter? Well, because our aim is to work with academic partners and SMEs and others to rapidly pull through technology as fast as we can to push forward the boundaries of what's possible with digital twins. Talking to Professor David Lane during my previous incarnation as lead advisor in number 10 on the integrated review, we were talking about how we think the integration and connection of digital twins will be as profound a revolution as the introduction of the internet. Once you have a, if you like, managed service or interconnected layer of multiple digital twins, an authoritative layer, what Bayes might call a national digital twin, potentially an international digital twin in time, you have the beginnings of the enterprise architecture of the metaverse, where connected digital twins will start with predictive maintenance and monitoring, but will rapidly move to management and optimization via faster than real-time simulation, both dynamic and deliberate, into a connected digital twin ecosystem where you can have telepresence, teleexistence, and more. And perhaps on another call, we'll dive into some of those elements. Nevertheless, that barrier to achieving this is still quite high. Just as the UK sets out its plan to do that in Bayes' innovation strategy in the integrated review, and Japan has something similar in its 6th basic plan for innovation, where they talk about Society 5.0, or the digital transformation of society where everyone and everything is a digital twin. That's Japan's vision, and being Japan, they have a deadline for when they're going to do it by 2025, and we aim to facilitate them doing it. But the barriers are both technical, which you are probably all more than well aware of, but also some of those are quite profound. If you have a world in which everyone and everything is a digital twin, it begins to ask questions about the power you're handing to those behind the tech. And so we're talking quite a lot about digital democracy and how we protect individual privacy and security in this kind of brave new world that we think is coming, and that we aim to accelerate into existence whilst also building trust in the systems that we work with. To the last bullet on the slide, why Fujitsu? Well, we have our history as a network and services integrator, but we also have a number of unique technologies that we will integrate into our solutions, and that's what I want to talk about on the slightly more detailed case studies. So one of the things we've done that we thought might be of interest is the tsunami forecasting in Kawasaki using Fugaku, which is the world's 2nd fastest supercomputer built by Fujitsu along with the Japanese Riken Institute. And it's been used for a number of things. I'm going to start here by talking briefly here. It was used for tsunami flooding forecast and then connected to the real world in order to inform decisions, so revolutionising decision making. What's the secret sauce of Fugaku? Well, the integration into the wider system should be familiar to everybody on the call. I imagine whatever you're working on digital twins, you have some solutions architecture that looks not a million miles away, just whether you're integrating human decisions or whether it's maintenance and optimizations of systems. What's different here, I think, is that Fugaku's computational power allows you to do much higher fidelity simulation than you would otherwise be able to do. So just as we have foundational models enabling AI at scale from GPT-3 and DALL-E and many that have followed, so you need that very, the argument that scale is enough in AI. You need huge computational power in order to run very high fidelity simulations to make more accurate predictions of cascading causal consequences, to answer what if questions. So one of the things we've used is in simulation for flooding. One of my colleagues was reminding me that this can be used also for simulation of forest fires, and then to inform local authorities immediately on what's happening. But the point is the high fidelity simulation that you don't get if you do this in a distributed cloud-based simulation, where you have to make trade-offs against both latency and also resolution of the data that you can feed into it. During COVID, we used Fugaku to do synthetics and simulation and modelling of epidemiology, and that was down to the individual molecules in people breathing out in bars and offices and restaurants to try to work out precisely the distribution of tables that people should adopt to try to reduce the spread of disease in Japan. So you can see they're kind of three practical real-world use cases for how supercomputing can be integrated into digital twin solutions, connected digital twin solutions, to improve and enhance decision making. Similarly, we provide flood prevention, in this case the UK flood warning system, to the Environment Agency, which draws on that same underlying technology and idea. And in this instance, we're bringing real-time data to individuals and organisations to inform about localised flooding, not the profundity of tsunamis in Japan and evacuation procedures, but localised warnings to inform the local authority. I wanted to say on this slide as well, we are similarly, when I talked about pulling technology through faster, we're working quite closely with MIT Centre for Brains, Minds and Machines on out of distribution data in artificial intelligence. And that's to be able to identify when there's water on the road that doesn't look the way the system expected to look, and yet it can still begin to identify something that wasn't in its training data and respond to it in a way that a human would. So we're trying to push the boundaries on AI to understand its limitations and then understand how you can apply it more effectively. And that's something we're looking to do within our reference model in the next year. So where are we now and what are we doing next? Well, we have the ongoing work on cognitive and advanced technologies that I lead through the centre. We have an agreement with Fujitsu Global to pull through a lot of the technologies that previously would have been developed principally in Japan and run them and test them in the UK to drive forward the UK's National Digital Twin Programme in support of BAYS, and to push forward the art and science of the connected digital twin, to try to get that to that enterprise architecture of the metaverse that I talked about earlier. More practically, we're focused on the Isle of Wight. You need a density of digital twins to prove the value of connected digital twins. There's no point distributing what you're doing. The key thing needs to be that density. So we're looking for partners, companies, organisations that want to work with us there. We are using our global footprint to make sure, and this is something I think we might talk about on a future call, to connect into all of the world's leading programs that we think might help to build that connected digital twins model. So whether it's Gaia-X or CADI in Japan for connected data, whether it's K-Twin in Korea, whether it's the 800 square miles of connected digital twins in Oregon, or work in Singapore, or work to build the Meta City in Riga, we're undertaking a baselining and benchmarking exercise that says, what is the state of the art, science, the innovation and business models that might bring this to us fastest? Who is leading, and how do we bring that back to the UK to show how this can be done to keep the UK at the forefront of developing the approach and the standards and the regulations that will enable us to build that digital democracy that I started with. So hopefully that gives you an overview of some of the unique technologies we can bring to bear in this work, and a few of the use cases that we've already developed in Japan and in the UK. On the slide here are links, which I'm sure we can make available afterwards, to the press releases in a bit more detail, and of course we can take questions or connect you to anyone that to connect those to the experts that you might wish to ask questions of on the specific use cases and our current work. So with that, I shall hand back.